So some of these you've come across. Oh, sorry.
On the page before, so I think I might have missed something. One of the equations goals is equal to something of this list of
Great. This one. Gradient, area under, and gradient again. Right. Okay. So you come across one equation of motion already, which is the first one, equation 1, the acceleration equation. Okay. So all of these equations of motion are if something is accelerating uniformly. So if the acceleration is constant. Okay. If you get changing acceleration, you have to do something. You have to sort of split it into parts to answer it. Okay. And you don't use these for constant velocity if something's accelerating. So you have come across A equals V minus U over T already, but we at higher level we write it just in a different order. Okay, so rearranging A equals V minus U over T, you get V minus U equals A times T, and to get V as the subject, V equals U plus AT. Okay, and they mean the same thing. So V is final velocity, U is initial velocity, acceleration, A is acceleration, and T is time. Okay. So the displacement from starting point is given by the area under the velocity time graph. We all know that already. So if we imagine we've got something starting at speed U and increasing until it gets to speed V. Okay, we get this graph. Okay, where U and V's are initial and final speeds. Okay, we've got this diagonal line in between it. So we can find the area underneath it by splitting it into a rectangle or a triangle. Okay, so for equation 2, that's how we start. So we look at equation 2, the S, the displacement, is the area under the velocity time graph. So area under graph. Okay, so that's area of the rectangle, so area 1 plus area 2. So area 1 is the rectangle, so it's length times breadth, so T times U. Okay, we don't have numbers, we've got letters, but if that was a 2 and that was a 6, you just times them together. Okay, so area 1 is U times T. And area 2 is a triangle, so it's half times base times height. So half times by this length here is V, take away U. So this whole thing is V, take away U to get that one. Okay, so half V, take away U, times by T again, because that's the length of it. Okay. Now, if we scroll slightly back up again, V minus U is AT, okay, from that equation there. So if we write that aside, that's supposed to be a star. V minus U is AT. So we can replace that V minus U with AT. So equals UT plus half AT times T. And yes, somebody whispered it there. So you can, again, make that meter. S equals UT plus half AT squared. And that is our second equation of motion. Well, it's up to you, but that's how it's written down in the equation list. Okay, so again, A acceleration T time, S is displacement, U is initial speed. You'll notice with this one, there's no V in it. Okay, so it becomes handy if you've been given information but you haven't been given the final speed. You can use this equation. Okay, equation 3, we combine equations 1 and 2. Okay, so equation 1 is v equals u plus at. Equation 2, s equals ut plus half at squared. So we combine. So if we start with equation 1, so v equals u plus at. If we square that, v squared is u plus at squared. So if we then expand those, so v squared is going to be u squared plus 2uat plus a squared t squared. Just because that's how you derive the next equation. Yeah, I've just squared it, just randomly, yeah. But you'll see why, because the final equation has a v squared in it. Okay. So, v squared is u squared. If we take the 2a, if we take a 2a out, so a 2a, and that's ut plus, well, we didn't have a 2a here, so we'd have to call it a half. Does that look familiar? Equation 2, ut plus half at squared. Okay? So v squared is u squared plus 2as. And that is our third equation. Yep. Okay, so from here to here. Right, so I took 2a out, so you can see where I've got 2a from here. So I've taken 2a, I've got ut. But guys, this is a good question. But obviously I didn't have 2a here, I just had 1a. Okay, so if I want to take 2a, I have to half this. So 2 times a half is just 1. Okay. So I had to half it to be able to take a 2a out. Okay. Why we didn't write it in that way? Somebody decided that was the best way to write it at some point, and that's in your equation list. Okay. Yeah.
Are we getting equations in the higher term?
Yes, you get equations. Yeah. Okay, and equation 4, we start with equation 2 again. So the s equals ut plus half at squared. That should be a 2, not a 3. Okay. So what we want to do now is we want to substitute for the a. So we know that a equals v minus u over t. So s equals ut plus half v minus u over t times by t squared. Are we okay? Just to get to where they wanted to get, I think. You don't need to. It's just information for you. But if you're interested in where it comes from. Right, guys. Guys, just because somebody asked a question. Okay. Right, so we can then get rid of that t and that squared. So now we've got v minus ut. So ut plus half v minus ut. Now if we take t out, we've got u from the ut plus half v, because if you expanded that bracket it would be half vt minus half ut. So minus half u. Simplifying that, u minus a half u is half u. It's still times, yeah, it's times them by. Yeah, exactly. Okay, guys, we haven't finished. So, to finish that off, we want to make it just look a bit better, really, than writing down half u plus half v. So, s equals u plus v over 2 times by t. And that's your fourth equation, which is the one that you come across. It's just average speed times time. Okay, and again, just to state that these are only used if you've got uniform acceleration. Look, I'll show you in a second. Okay, guys. Okay. Guys at the front. Okay. Right, guys, back. Okay, so we're going to go through some examples of using these equations. Okay, and these equations are quite handy because each one of them is missing one of the letters. So we've got in total S, U, V, A, T. Okay, and we often refer to these as the SUVAT equations, S, U, V, A, T. But each equation is missing one, so we don't have S in the top one. We don't have V in equation 2. In equation 3, we don't have T. And equation 4, we don't have the A. Okay, so they are useful if you're only given a certain amount of information. So you have to look at the equations, decide which one you want to use. Yeah, yeah, you get them in the equation list, yeah. Okay, so you'll see SUVAT written down there. Now, obviously, it's not going to be written down for you, but the first thing you want to do is write down, when you're using doing these kind of sums, is write down SUVAT. Okay, so example 1. A car accelerates uniformly from rest at 2.5 meters per second squared. Calculate A, its speed after 5 seconds, and B, the distance travelled after 8 seconds. So we write down SUVAT, S-U-V-A-T, and then we fill in what we know. So it accelerates uniformly from rest. So U is our initial speed, and it's going to be 0 because it's from rest. V, well, A, it's asking us to calculate the speed after 5 seconds. So V is our question mark. It's what we want to find out. A is the acceleration. We're told is 2.5 meters per second squared. And part A, the speed after 5 seconds, so our time is 5 seconds. We are not told anything about S in part A. So we need to look at those equations again, and we need to find out which equation uses V, U, A, and T. Okay? And that is V, the first one, V equals U plus AT. V equals U plus AT. And then all you need to do is put in your numbers. So you've identified U is 0, our acceleration is positive 2.5, and our time is 5 seconds. So the final speed after 5 seconds is going to be 12.5 meters per second. Okay, you guys have a go at part B. So write down your SUBAT, what you know, and then decide which equation you want to use. It's still accelerating from rest. Guys, this front, have you got the answer? What have you got? Right, guys. Okay. 88. Okay. So, for part B, we want to know the distance travelled after 8 seconds. So it's starting from rest, so U is 0. Guys. We don't know anything about the final speed, we're not told anything about the final speed. The acceleration is 2.5 again, and our time is 8. So we want something without V in it, so S equals UT plus half AT squared. U is 0, so 0 times T is 0, plus half times 2.5 times 8 squared, which should come to 80 meters. Did most people get that? I know there's a couple of people. Okay. Right, example 2. A racing motorbike, initially at rest, reaches a final velocity of 75 meters per second. After covering a distance of 400 meters, calculate its average acceleration. So our acceleration is the question mark, is what we want to find. It covers a distance of 400 meters. Initially at rest, so our initial speed is 0. Reaches final velocity of 75 meters per second. But we're not told anything about time. So the equation without time in it is V squared equals U squared plus 2AS. And then you just put the numbers in. So 75 squared, please remember to square anything that has a square, is 0 squared, so 0, plus 2 times by the acceleration, which is what we want to find, times by the displacement, which is 400. So you end up with having 5,625 is 800 times acceleration. So the acceleration comes to 7.03 meters per second squared. Any questions so far? Anyone not getting the right answers? Right, example 3 is one of these ones where the acceleration changes midway through it. So we've got to take it in parts. Okay? For an object, guys, initially at rest experiences an acceleration shown below. So we've got a graph, it's 6 meters per second squared first of all, the first 2 seconds, and then it drops to an acceleration of 3 meters per second squared for another second. So it says, first of all, calculate the speed of the object after 3 seconds. Okay, so we're looking at the whole motion. So the acceleration has changed. So what we need to do is we need to split it into sort of motion A and motion B. So what we need to do is find the speed at 2 seconds and then use that to then find the speed at the end. Okay, so find speed at 2 seconds, first of all. So we're looking at A, section A. So we still have to do SUVAT. We don't know anything about displacements. U, we're told it starts at rest. So U is 0. V is what we want to find. The acceleration for the first 2 seconds is 6 meters per second squared, and time is 2 seconds. So to find V after that first section, V equals U plus AT. So 0 plus 6 times 2. So 12 meters per second at 2 seconds. But that's not finished. We need to find the speed after 3 seconds. So that is our initial speed when we get to this point. Okay? So initial speed for section B. So if we look at section B now, we do SUVAT. Initial speed is 12 meters per second. Final speed is what we want to find. The acceleration is now 3 meters per second squared, and it goes on for 1 second. Again, we don't know anything about S. So again, V equals U plus AT. So V equals 12 plus 3 times 1. So 15 meters per second at 3 seconds. Okay, so a little bit more complicated. Remember, you can only use those equations when the acceleration is constant, so if the acceleration does change, you've got to separate it out. Okay, so for part B, same thing happens again. Total distance travelled by the object, you need to look at section A, find the distance, and then look at section B, find the distance, and then add them together. Okay, so do you want to have a go at that one? No, because it's an acceleration time graph, so you need to use SUVAT again to find S. Yeah, you'd do that if it was velocity time graph, but it's an acceleration time graph. Now we basically know everything, so you can use whichever equation you want, but I would use the one where distance is the subject. You get it from the graph.
You already have it. What was the answer? 25.5.
Yep, that's right.
Alright, yeah.
I've got part C as well, if you want.
Why is it? Oh yeah.
Ready?
Yeah. Why is it? No, that's it. Why is 2 seconds not just a full 3?
So, because you need to split it into the two because the acceleration changes midway through, so you have to split it. It won't. The equations won't work if you try and use it as a one.
Can you just use average velocity equals displacement over time?
Yeah. So the answer should come to 25.5 meters. So you use S equals UT plus half AT squared. You can use any of the other equations, but I think this one's the easiest one to use. So you get 12 meters for section A, 13.5 meters for section B, and then you add them together to get your final answer of 25.5 meters. And for part C, you don't need much space for this one. The average speed of the object is just distance divided by time. So everyone okay with these? Getting a little bit more complicated.
I don't know what example 4, sorry.
Again, if you finish this, you want to have a read through the next example, you can do, but I will go through it. Okay? For section B, probably 4 marks. Yeah, because you use one equation, because you use the same equation each time, and then you'd have 2 answers and then add them together. It would be an extra mark anyway. Are we still writing? Yeah, I'll leave it for a little bit longer. Right, guys. Is everybody still writing? Okay. So example 4. Guys, example 4 is the start of having to think about signs. Okay. Now this one, we're okay because it's just going in one direction. But later on, guys, we will have to start thinking about things that change direction. So we're going to end up with some negatives involved. Okay, so a ball is released from rest and falls vertically, so it's not going up or anything like that. When it hits the ground, it's traveling at 29.4 meters per second. calculate the time it takes to reach the ground. Okay, so it's going down the way. Okay, what is his acceleration? Yes. Okay, we know that the acceleration due to gravity, if something's just dropped, is 9.8 meters per second squared, and that also acts down the way. Okay, so because we're looking at the downwards motion, we're taking the speeds to be positive, and it's the same direction as gravity. Okay, so S we don't know anything about. U, it's dropped from rest. V, the final speed is 29.4. Acceleration 9.8, and the time is what we want to find out. So we just use V equals U plus AT, the one without S in it. So 29.4 is 0 plus 9.8 times by the time. So time should come to 3 seconds. Okay, this is where this little piece of paper comes in. So once you've written that, you should have a space underneath it. That's where it's going to go. Because it's important to start thinking about the direction that gravity acts in. Okay, so which direction does gravity act in? Downwards. Yes. So if you throw something upwards, then your acceleration you have to take as negative, the opposite direction to your upwards. So if something is being thrown upwards and you want to find what the speed is at the top, then your acceleration is going to have to be negative 9.8. Okay, so that's what this is, a little bit of an explanation on that. So if you have a read through this, it says for an object being thrown upwards or falling vertically downwards, its acceleration is always g. So 9.8 newtons per kilogram or 9.8 meters per second squared. No, sorry. Yeah. Just take it home and learn it at home. Okay. So, actually, let me get this in front of me. There we go. For an object being thrown upwards or falling vertically downwards, its acceleration is always g. Guys, it's important you listen to this, because this is where everyone slips up. So g always acts in the downwards direction, so towards the centre of the earth, so we need to be careful with signs. So for example, if a ball is thrown upwards, we would usually choose upwards to be positive. We usually choose our first initial motion to be positive. So the acceleration would be acting in the opposite direction, so you'd have to say that's negative 9.8. Whereas if a ball is dropped downwards, we usually use downwards to be positive because that was our initial direction. So the acceleration also acts downwards, so it has to be the same sign as your downward motion, your downward speed. So it would be positive. Okay, we will do some examples of this another time, but I think that's enough talking for me. So what I'd like you to do is just have a reread through the examples if you need to, or otherwise page 4 to 5 of your question booklet is all these kind of questions. Okay, so do that, write down everything you know, then put it into the correct equation. Okay.